I think the smartest way is to recognize that if this is I1, right, which has an x sine x on blah, 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 and this is I2, which has a minus x sine x on blah, blah, blah. When you put these two together, rather than dealing with them separately, right, these guys are going to cancel. That's really good, right? So here's the way that I started my working. I said I1 plus I2. What's it going to be equal to? It's two integrals, but they share the same boundaries, and they share the same variable of integration, so I can just combine them. Okay, so this is what I get. Or with respect to x. Okay, so you can see my x sine x's cancel, this guy and this guy, right? So now we should get this. Now a small number of you got a little too enthusiastic with your cancelling out of terms, and your x sine x and your x sine x, they cancelled, and that sine x also just disappeared. So all you end up here with pi. And I was like, oh, okay, that's a shame because it drastically simplifies the question. So even though this is something I should mention to you, if any of you have this, we've talked about this before, you know what that means. It means you made an error and you carried it through, but everything else was correct, okay? A small proportion of you, and I don't know if any of you are actually sitting here, if it's other people whose papers are there. If you ever see me write this is a less of a common code, but it's still an important one, right? Sometimes you can make an error early on in your working, such as this one, leaving off the sine x, right? That's an error that you carry on. Now, even if you do everything correctly from here, assuming it's pi on 1 plus cos squared, okay? Even if you do everything correctly, the error you've introduced has simplified the question dramatically. So you don't just lose 1 mark. You'll lose more because you're not doing the same amount of work that everyone else is. You've made an error and you've made it simpler, okay? So you've got to watch out for those. They're nasty. Now, once you get to here, which is correct, you could either see that you can use reverse chain rule straight away, or maybe, if you're a little concerned because of boundaries and so on, you can say let u equal cos x, and then you can go from there. Do you want me to keep on showing you how that works, or do you think that's enough? Show you? Yes? No? Yeah? Okay, I'll really quickly do it. You got negative sine x, so you get new boundaries. The lower boundary becomes this. Your upper boundary becomes this. Oh, by the way, that was a place where some errors crept in. People saw this, right? And they went straight from x equals 0 to u equals 0, which was a big mistake, clearly, right? I think because people got confused between which function was actually u, because I think we all know that cos 0 is 1, but you rush, you see that together, you have to be very careful, okay? Right, so once you've done this, you can chuck that pi out the front and you'll have, hold on. Oh yes, that's right. It is a bit unusual that your lower boundary is bigger than your upper boundary, right? But that's okay. We know how to deal with this in integration, right? You go from 1 to -1, but you've got a negative up here, right? So I can use that to turn the boundaries around. So you get this. The boundaries look like they're going back the way that you're used to, right? So that's tan inverse. And some of you did go straight to tan inverse of cos x, and that was fine, okay? So what are we going to get? You're going to get pi on 4 plus pi on 4, because this is going to be, this is minus tan inverse of -1. Minus tan inverse of -1. That's a lot of minuses. But you can see that's what makes the positive there. Okay. And that's where you get this. Okay. One last note before we leave this question. There was a free mark at the end of part A, which some of you threw away because you ended up being confused about parts 1, 2, and 3. Part 4 asks you to evaluate the original integral, like this. Right? But being that you already know so much information, you've had to prove so many steps earlier on, right? It was like 2 lines, or 3 lines, I suppose. We know what this result is, I1 plus I2, right? Because we just worked it out here. It's pi squared, 1, 2. But we also know that I1 and I2 are the same, right? So this is actually 2 times I1. right? I1 plus I1 on that side. So you just had to divide by 2, that's all. So there's an exam technique for you when you are rushed and confused and don't know what else to do but are scrounging around for marks. Look for those multi-part questions. Often the last part is just trivial. It just depends on you using the previous parts properly, that's all. Okay.